Okay, let's start from day one. Circumference formula, you're going to go in knowing. Circumference formula. 16, circumference formula, you're going to know and going. Pi d, yep. Or if you're a 2 pi r person, that is also acceptable. Angle AOB is called a what angle? Angle AOB is called a what angle up here? Here we go. 16 again. What type of angle is that? Central angle. Any angle that's at the vertex is called a central angle. How do you find its measure? What is the something? It has a relationship with something else on this diagram. Angle AOB is the same measure as, here you go, 29. Okay, name the arc, Billy. AB, there you go. Those two have the same relationship. Not done yet. Hook me up with a minor arc on my diagram. Hook me up with a minor arc. 2, hook me up with a minor arc. AB is a minor arc. And then hook me up with a major arc. One, Matt. Whoa. All right, go ahead, stud. ACB caught me off guard. Oh, good. Let's do this again. ACB. Nice job. Good so far. I got more for you. Formula for arc length. Formula for arc length. Not the arc measure, the arc length. All right, I'm just going through everything we're going to need here. As you guys, hopefully I'm proving myself that there's a lot here. 5 arc length from the from 2 days ago, a couple days ago there. Measure over 360 times circumference. Boom. Okay, we all good there? Because I'm going to use that one again today. I'm going to use that one again. Hi.
I forget, if you already have the circumference at the start when you're putting that equation, can you just replace that with the pi? Can you just replace the pi d with the circumference?
Yeah. Yep. Radians to degrees. Multiply by radians to degrees, everybody. I'm going from, I have radians, so like 2 pi over 3 radians. What do I multiply it by to change it back into degrees? On your formula sheet, remember, 18. What do I multiply it by? 180 over pi. And then finally, degrees to radians. Multiply by 22. There we go. Guys, that's just 3 days right there. Just 3 days. Okay, I'm not trying to scare, be critical of people. I'm just trying to show you a real deal here. We got a lot already, and we're only on day 4. Questions at all about what we've done? I think the quiz will be sometime next week, early next week probably. Actually, I can see your packet. Yeah, so it'll probably be Tuesday. All right, for you guys, Tuesday for geometry AB. All right, Tuesday after day 7. Okay, after day 7. All right, let's do this. There's not much today, but might get a little confusing. Quickly, what's today's topic on top? Haven't we talked about that already? We just went over a formula. What formula did you guys just give me for arc length here? 8. What formula did you guys just give me for arc length? Oh, boy. 25. So why are we doing this again? Here's why. What are you putting up there for arc measure? Degrees. You're going to put what it is in degrees, but we found out yesterday there's another way you could measure an angle, and how's that? In radians. So what if I'm given the radians instead? That formula we've been using, worthless. All right? Everyone see why? Because what do you need the angle, what do you need your arc measure to be in? Degrees. It's worthless. Unless you want to convert, maybe. And I'll talk about it at the end of today. All right? So what if the angle's in radians? I got another formula for you. I know you're excited. Okay? Here's your new formula. Theta, I'll talk about that in a second. That's a Greek letter. We may have seen it before in a couple units ago. Theta equals, ready? S over R. What does each piece mean? Here you go, kids. Theta, that's the central angle measure. But that angle better be in what type of units if I'm going to use this formula? Why am I showing this to you? It's got to be in what type of units, that angle? What do we call that from yesterday? Radians. Radians. It's got to be in radians for you to use this formula. As you can see, the pen is not really cooperating. All right. You're probably wondering what S is. Arc length. That's probably what I'm going to ask you to find. Arc length. That's the length of the arc is S. And you superstars want to guess wild guess what R is going to be? Radius length. Most of the time, though, I'm going to ask you what's the arc length. That's most of the time. I'm going to ask you for the arc length. So wouldn't you want something that says S equals instead? So you could just plug it in and you get the arc length. Because that's most of the time, that's what I'm going to ask you for, is what's the arc length of this circle? What's this arc length? What's this arc length? So instead, here's the formula you may want to remember. What starts with S. Anybody know what's going to happen? If I want to get S by itself, what do I do with R? It's going to be theta times R. SOR, some kids like to say. Okay. So the arc length is equal to the angle times the radius. Okay. Angle times the radius. Still finding arc length, but it's got to be in radians to use this. Okay, take a yes, Thomas.
Can you just repeat what that symbol is named again?
Theta.
Theta.
Theta. Theta. It is a Greek letter.
Yes.
You're welcome. Usually used for angle measures in mathematics. Other questions? Any history of math questions before we move on? Okay. Here we go. Number one. Find the length of the arc S. Everybody stop, because I got two formulas here. I got the one we've been using and this new one I just threw at you. Is the angle, is that pi over 3? Is that degrees or is that radians? It's radians. Again, what is it again? Radians. So which formula am I going to have to use if the angle's in radians? S equals theta R. If you tried to use the other formula, that would work because this has to be in what? Degrees. I don't have degrees. All right, let's help me fill it in here. S equals, what's the angle measure? 6, the angle measure. Pi over 3 times the radius length. 6 again, 5 centimeters. Yep. And what am I? Round all answers to the nearest hundredth. All right. So not in terms of pi. So everyone go ahead. That's why I had you get your calcs out. Pi over 3 times 5. Five. What do you have for me? 5.24 centimeters. Good. Remember your units, everyone, especially if your diagram comes with them. 5.25 centimeters is that arc length. Does everyone see we have two formulas for arc length? One is if the angle's in what? Degrees, and I got this other one I'm just showing you now, which is if the angle's in radians, okay? We'll talk at the end here how you can only remember, where it might be okay if you remember just one of them, all right? But I'll wait to the end. Next one, finding S, what's the angle in? Radians or degrees? Radians, so S equals theta R. $17, here we go. What's the angle measure? 10 pi over 9. I won't ask anybody this, times the radius of 27. What do you got when you round here? 13 when you round. Thank you, Emily. There you go. Questions? Going. All right, so far all I've asked you for is solve for the arc. Now I want the angle, and now I'm going to push you. Push you, because I want it in radians and the angle in degrees. Going back and forth. All right, I want it in degrees, and I want it in radians. All right, ready? What's the 16 here represent? Radians. What's the 8 pi? What am I giving you here? That's the arc length is 8 pi. It's not the angle measure. It's the arc length is 8 pi. Everyone good there? So we can use either formula right now. But if you look at the two formulas, guys, which one probably is it easier to deal with out of the two formulas for arc length we've given you? Hey, remember, you got this one. Times pi d. And then this one I just gave you. So ready? Is it easier to solve for this in this equation or for theta in S equals theta r? Which one's it easier to solve for probably for us? Okay, then why don't we do that then? We'll use this one. Can you use this one? Yes. Okay, because do you know the arc length? So I put 8 pi here. X over 360 times pi. Do we know the diameter? So you could use this, but it's going to use some heavy algebra. Versus this one right here. Come on. There we go. What's getting plugged in for S now? Here you go, 24. What's getting plugged in for S? 8 pi, arc length. Theta is going to remain theta. And now what's getting plugged in for R? 6. What's getting plugged in for R? 16. Divide by 16 on each side. Will this answer be radians or degrees? Look at the formula. Look at the formula I use. Will it be radians or degrees? Radians, so you better leave pi in your answer, right? What's 8 over 16 reduced down to? Half, so pi over 2, or 1/2 pi. So that's in radians. How do you make it into degrees? I don't want to go back to this formula either. I refuse to, because we just spent all day yesterday going from radians to degrees. So go back, look at the conversion if you need to. In degrees. What am I multiplying pi over 2 by? Here you go, 9. What am I multiplying pi over 2 by? So pi over 2 times 180 over pi. What cancels out from yesterday? Pi's are gone. And in degrees, 90 degrees. So in radians, it's pi over 2. In degrees, it's 90. Questions? Yes, Nam. You can do that too, yeah. There's so many formulas. I just remember, but if you want to do that, yeah, that's fine, because that right there, what you told me is the same as this formula right here. Okay. Okay, next one. Solve for the angle again, so we'll keep using S equals theta R. What's my arc length in this case? 27, arc length? 15 pi over 7 is equal to theta times radius of 5. Still divide both sides by what? Divide both sides by 5. Okay, you're going to have to get a fraction template, it looks like. A couple of them, probably. Remember, keep the pi in your answer because it's in radians. Go ahead. So what is 15 over 7 divided by 5? Leave the pi in your answer. $14, what do you have there? So 3 pi over 7? Come on. Yep. I'll you guys go ahead. You convert. I'm not going to hold your hand on this one. Go ahead. Convert it into degrees. And go nearest tenth on here for me because it's not going to be pretty. All right, go nearest tenth for the degrees. In degrees, what do you got for me? 24, what do you have? Yep. Questions from you guys? And two word problems, it looks like, to end this. 3. Oh, sorry. Oof. What was I thinking? All right, I always have to go to the old Google Images for this one because I got some youngsters in the class. The pendulum of a clock. Any idea what we're talking about? Pendulum. What do we? Here you go, kids. Pendulum clock. All right, that's this bad boy right here. The part that hangs down from the actual clock face. Okay, everyone good there? Pendulum, yep, oh, that's cute. Got the umbrella handle for the pendulum. That's a little weird, that giraffe. Would not want, got to always have the shark in there, right? What do we, I don't see, what's the there's no pendulum there. Oh, it's mouth. Oh, that's cute. The fish in the mouth there. I'll look at that. Rainbows, cloud with a little unicorn there for all the kiddos. Oh, the trunk of an elephant. Look at that. So creative. Oh, look at a little fire coming from the rocket. Paintbrush holder. These pendulums. Oh, that's beautiful. Submarine, little octopus hanging off. Okay, the owl and the moon. Okay. Got the fox and the tail. There it is, the robot. We get even better here, guys. We could spend all day on this. Pendulum clock sounds, not too sure. That's creative, the ice cream cone. All right, that's a little weird, but okay. The little whale with the crab hanging out there. That's a little weird. Train with the little train. Yep, little tree coming off. I don't know what that is. The bear. Bear with the. Why would a tree be hanging? That doesn't make any. That's weird. All right, that's really about it. It looks like a little birdhouse. Yep, there you go. Yep. Wow, unbelievable. Everyone all right? And then the old mixer with the cupcake. All right, I'm done. All right, so we're all good with pendulums. Nice little break in the action. Swings through an arc at 2.5 radians. All right, hold on. What's the 2.5 going to be? First of all, radians. So which formula do I want? SOAR, S equals theta R. Where's the 2.5 going to go in for? Angle of 2.5. Where's my 2.5 going to go in for? Which one represents the angle up here? Theta. So equals 2.5. What else am I given? It travels through an arc of 50 centimeters. Where S, 50 equals 2.5. The length of the pendulum is another name for the radius length. The length of the pendulum, yes. Is everyone all right? Why I'm using the formula and why the numbers are what they are when I plugged them in. All right, what is the length of the pendulum? We'll go back to the pendulums there. 18, length of the pendulum. What is it? 20 centimeters. Again, thank you for the units. All good. We okay? Again, seriously. Why do we pick S equals theta R versus the other one? This is in radians. Everyone all right? Why? Theta was 2.5 and the arc length 50. Okay, I need you to try one on your own. Okay? I need you to try one on your own here. Let's see if I can catch anybody here. You might want to talk to some of your group members while you're doing this. Some of you guys think you're done, but you're not reading the problem. Two, what formula did you decide to use? Because I am told about arc length here. So two formulas, which one? S equals theta R, because it's in the angles in radians. All right, what'd you plug in for everything here? 18, what'd you plug in? Where'd you plug the 3.5 in for? Theta, yep. And 21, where'd you plug the 24.5 in for? S, that's arc length. So that's what I saw a lot of people do. They're like, yeah, got this. Divide by 3.5, R equals 7, we're good to go, but I didn't read the problem. I was looking for what? Diameter. Yep, you're almost there. What do you want me to do next? 22? Multiply 7 by 2, so the diameter is actually 14 units centimeters. Okay? Questions? All right, let's see if I can wrap this up here. We can wrap it up. In number 7. We're going on a cart on a circular track. Look at that. What's the length of minor arc AB? So we're looking for this distance right here. Minor arc, how long is it from A to B? All right, let's talk. Everyone just stop. Can we just stop and have a quick conversation before we get after it with the numbers? What's the angle right now? 165 degrees. So looks like I got to revert back to my old one. Okay? Which is fine. But how many of you are like, boy, whew, this formula is nice, it's short, and I can remember it? Everyone agree with that? Yeah. You probably want to use it every time, right? Instead of trying to pick. You can. You can use this every time. Why can you use this every time? You can't use it with 165, but what do you have the ability to do with the 165? Convert it into radians, then plug it in for theta. So that, guys, that is going to be your call. Do you remember both? Or you just remember one, but if you remember one, you got to convert every time if it's not in the appropriate units. What do we want to do in a class? Do we just want to take the 165, plug her in? Or do we want to convert and use theta equals? How about we just do both? Why not? It'll satisfy everybody. Okay, it'll satisfy everyone. Okay, you guys that want to plug in. All right, here you go. L equals 165 over 360 times pi. What's your diameter? Not 2.4, Fiona. 4.8. And then you guys go ahead and get after it. Nearest tenth of a meter. You guys that want to convert, let's do it. You guys that want to convert, what do you got to multiply 165 by? Pi over 180. So that'll be, I have no idea what it turns out to be when you reduce 165 divided by 180, reduce that sucker. 11 pi over 12. So now when you guys that just want to use S equals theta R, I got S equals, what do you plug in for theta now? Not the 165, but 11 pi over 12, and multiply that by the radius. Either way, we're going to get the same answer, which would be 6.9 meters. Same thing up here, 6.9 meters. So yeah, if you want to handle it, just memorize one. But just remember, you may have to convert if it uses degrees or if it uses radians. That's all I ask. Okay, do not give up. Call me over if there's a question. All right, let's go. Call me over if there's a question. Do not give up on the homework.